Hello, everyone, and welcome to the WEDA's webinar for June, overcoming the performance of materials such as metals. My name is Robert Ramsdell. I'm the moderator for the session. I'm an independent dredging consultant with Dredging Resources, and I will introduce our speaker in a moment. But before I do, I should note that we're recording this, and I'm going to go over the rules of engagement really quickly. Please use the chat to introduce yourself to the other attendees. If you have questions during the thing, there's a Q&A feature. Use that rather than the chat. That way we can capture your questions and make sure they get answered. If there's any technical issues, it's easiest to log out of Zoom and then log back in. And if that doesn't work, you can you can put it in chat or contact Tom directly or email info@westerndredging.org. We'll be monitoring that during the thing. The recording from today's webinar will be available on the website later tomorrow. You will receive a thank you email and that you can use to request your professional development hours. And if you're not currently a member of WEDA, please consider joining. And if you're uncertain of the status of your membership, you can contact Tom at info@westerndredging.org. Let's see. So Renzo, I'm going to introduce our speaker today is Renzo Taffarello. Renzo, if you can turn on your camera so we can see you. Renzo has more than 30 years experience in international markets. He's been a member of various boards. Currently, he's on the board of Chiasma, where he's in charge of international strategy and innovation. Mr. Taffarello's current focus is on the dredging industry, emphasizing material technology, AI, ML, big data, and their applications for sustainability and green near zero emission operations. Mr. Taffarello is also a member of technical scientific committees and a scientific coordinator of research projects in collaboration with universities with grants from the local government and the EU. He graduated in electronic engineering from Padova University, Italy, and has a MBA from Clemson University here in the United States. Renzo has worked with Stanford Research Institute International, Alenia in the Aerospace and Military Division, Anderson Consulting, and as a contract professor, Professor Taffarello has held courses at Venice University, Ca' Foscari on applied economics, information management systems, and human-centered design. So thank you, Renzo, from the WEDA Education Commission for taking time to educate our membership. I'll go ahead and hand the slides over to you now.
Thank you, Robert. Let me put on my slides. Should be on, I guess. Thank you for hosting me here in this event. And here what we would like to do is to share with you what we found out in the discharging pipeline technology and systems connected to the fact that we found out that the discharging pipeline can be a source of profit or in any case affect the profit of the operation. What I'm gonna to tell you is we are expert in the pipelines and made with material like HDPE. It's our bread and butter. And that's the major findings that we have is about using this type of technology and materials. And what we were a little bit astonished in the years that is about the fact that everything is getting smarter. Everybody in every field and every production device are making everything more intelligent. And it seems that pipe for dredging is not getting so smart. So because this is our industry and it's our field of expertise, we started to look at this not just a part of a problem, the pipelines and the way they are manufactured and used, but also find out the way that we can make a better performance in terms of wear out, controlling the blowout, and having different performance in terms of breakup of the material. And we found, and that is the main aim of this my speech of today, is that we can achieve a lot of good results and performance and also economic benefits if we go from generic to specialized product for the dredging industry. What I would like to point you at the end of this this hour of discussion, the presentation, is that discharging pipeline is a factor for improving the profit. And the profit comes from specialized solutions. And profit and sustainability go together very well. This is not a commercial pitch. What we are going to share with you is our finding from our technical research and development department, working in the field with the customers and the projects, but also with the university. As Robert mentioned to you, I am working with the University of Padova, which is nearby Venice. We are located there, basically. And also in Ca' Foscari, which is the University of Venice itself. So we used also the university, we engaged the university for this type of research and helping us in understanding what we are getting from our research. In order to take you in this field, what I'm going to tell you today is a very brief crash course on discharging technology and the production and economics behind that. It's a way to put everything all together because what is one of the findings for us is that the main result is not just looking at the single components in the pipeline, but looking for the overall systems. So I'm going to take you into that today. And we start usually thinking that a pipe is a pipe, but for people that are working like us into this field, the pipe is a system. And the sketch that I put in the screen is something that came up from our brainstorming years ago, and we found out a lot of things and components and technologies that goes into the systems. And they affect the dynamics, the mechanics, and the economics of the whole performance of not only of the pipeline, but of the overall dredging project. So let me take you step by step. The first one is about material science and the connected production techniques that allows to have very astonishing results on that. Of course, let me point out again that we are talking about HDPE-based materials, but you will see now that we can improve a lot of this situation, adding compounds and many other things. So this is the type of product that we are working on, we worked on, and is currently in the market, but is not very well known for its astonishing performance. It is a product made, a multi-layer product made with different type of materials. Some of them are not really compatible, and we found out the way to make them compatible. Let me just make sure that we hit the important point. This pipe is a multi-layer pipe. It has an outer layer, which is made with HDPE. And actually, we are not using the traditional PE 100, but the PE 112, which is, you will see in a short, that is a very different animals than the PE 100. And the inner layer is a TPE, which is elastomeric compound designed especially for the dredging application and mining also. Let me explain a little bit more. During the years, you have seen in the market pipe made by HDPE, PE80, and then the PE100, which improved a lot of the performance. We know that the blowing of the pipeline is a real concern, so it improved quite a lot from the PE80 to the PE100. But the biggest jump in the performance comes with the PE112. You see in the sketch that we have the molecular structure and the difference between the PE80, PE100, and the PE112. And that makes the pipe made with the PE112 much more resistant to the pressure, but also, and you can play with the pressure and the thickness of the pipe according to your need. So that gives also some advantages in terms of the price and the cost in the production. But the most interesting thing is the inner layer material. We found out, and you see some of the movies, video clips in the bottom of the slides, we found out the way to co-extrude material like the elastomeric based one with the HDPE, which is plastic rigid one. The very interesting finding you see here in the red circles, you see the abrasion loss. And I want to really spend a few seconds more here. You see the abrasion loss having the material going through the pipe. It goes dramatically down from 152 millimeters down to 40 millimeters, 48 millimeters. It means that the awareness of the thickness of the pipe has improved the performance, and basically the same thickness lasts 3 times more just because we added these inner layers of material. And this is the type of situation that we measure in the field. We are lucky to have a couple of test fields, and which are the quarries, where we have dredging operation going there that we test our solution. And you see the consumption in the black in the left side. You see in the bottom of the pipe the big consumption, and in the right the red pipe, which has almost no consumption at all, having run a lot of cubic meters of material inside that. So this material has a very big effect of anti-abrasions, and it improves a lot the performance of the pipe. And that is what comes out from our production site. It's co-extruded, and it has a very significant resistance to the abrasion. But also we found out that we could add other additives into the inner layer and to have a friction reducing effect. And this is another interesting fact. So we could see that we could put into the TPE compound, which is in the inner layers, something like the PTE FE family type of material, which acts like a kind of a lubricant. PTFE is like is Teflon-based stuff. Again, the trick or the difficulties was to make sure that you can co-extrude at the same time and chemically bound the HDPE material with the elastomeric and the Teflon-like material too. So in such a way, we could have the outer layer, which is the structural part made in the HDPE. And then we can have either together the effect of anti-abrasion due to the elastomeric part and the friction reducer as the other component that we had in the compound. In a kind of way, it's in order to show you the real effect of this, in this chart, you see that we can extend the life of the pipe almost from 2 to 4 times. Of course, it depends on type of sediments you are running into that, but definitely is a very significant and amazing results. And as you see, the red curve, it has 2 different slopes, and the first part of the slope is due to the inner layer, which is very resistant to the abrasion. So a pipe like this made specifically for the dredging operation has a very significant impact on the operations and, of course, in the profit of the operation. Here again, I want to just to underline into the, you see into the red circles, the big results of this type of pipes due to the performance in the abrasion compared to the other, like the PE, HDPE 100 or the steel pipe 2. Just for this part, I wanted to conclude to say that highly engineered pipe means that they are specialized for the dredging. And we joke to say that this type of pipes is like the tire for the dredging. The tire for cars, this pipe is the tires for the dredging, because it's so highly engineered that can achieve this type of performance. And the takeaway from this first part of my presentation is that there is a real increase of the resistance to the pressure. There is a very good anti-abrasion that extended the pipe life 2 to 4 times. And due to the fact that the material flows better, we can have also a savings in the energy. So again, another factor that increases the profit of the operation. Let me take you to another area of the system of a pipeline, which is the sediment flows dynamics. Here, we tested we know that how the soil, the sediments behave and how they affect the pipe. We worked in several projects all over the world in different type of environments. So we had the chance to accumulate a lot of knowledge about the sediments. We know that if we, and it's common knowledge, but it's not easy to apply, that if we are able to make the sediment dancing, we call it, or having a rifle effect where the sediment can flow in a kind of propeller way inside the pipe, you can have a lot of good, better performance in terms of throughput, in terms of the fact that the sediment is not going into the bottom part of the pipe and so on. But I wanted to point out again that because the sediment flows easily into, or easier into the pipe compared to the other situation, you can have an energy reduction. And from our first test that we have done in the quarry, it's about 70% of energy reduction at the pump effort in order to push the material through the pipe. That is from our analysis, and we found out that the trick is if we want to have a flow as much homogeneous into the section of the pipe, we needed to include, you see into the bottom right, the inner part of the pipe, we need to include a kind of fins or winglets, we call it. The difficult part for us was to study the geometry of the position and the way that they should have located into the pipe. And we found out some optimal solution, working also in the analysis with the computers and also from the field. This is a kind of result that is very important for us, because we found out the kind of system of parameters, geometrical parameters, in order to place the proper winglet inside the pipe. One thing that I wanted to point out is that with the HDPE-based pipe, you can do that pretty easily. With other type of material, it's quite difficult or impossible, or it will cost so much. So again, just to share with you some results of our analysis and comparisons from the field. You see, we have two types of graphs here. We have the power pump, and which is fixed, and the length of the material pushed through. And as you see in the red circles, the pipe that we made with this rifle effect. We, in our internal code, the name is KFC, flow control systems. You see that the material moves quite farther than the other pipe without the system of rifle. Or vice versa. The other graphs is you can lower the power pump at the pump point in order to reach the same distance. So you have benefits about that. You have a reduction of the abrasion, pressure loss, less pressure loss, and in some way you increase the productivity at the end of the pipe. You have more material, and combining this, you also have lower CO2 emissions, and in fact also reduction of microplastics. So this is an effect that is good for the environment. So sustainability is enhanced from this point of view. Okay, here is just to show you that we have measured also the pressure loss, and we found out that we have 1/3 pressure loss compared to the traditional system without the making dancing system of the sediment. But also we have another improve in terms of abrasion and loss of the thickness into the pipe. Having the material goes in a rifle way, and a more homogeneous section of material going through the pipe, we have another 20% increase in the performance of the thickness. You see that we, in our best case, we have a 48 millimeter of abrasion, and with the rifle effects, we are able to achieve roughly the 40 millimeters of material. So it's good, it is for the projects. The takeaway from this part for you is that if given the fact that the pipeline performing this way, depending on the cubic meters that you have to produce, probably you do not need the rotation of you do not need to rotate the pipeline. And if you think that anytime you have to stop the dredge for production in order to rotate the pipeline, that gives you quite a good improvement in terms of productivity and, of course, in terms of profit. These kind of systems from our production comes out with some increase in cost and the price, of course, but the cost is about 5 to 10% more if you are including the winglets inside the pipeline and made, of course, in HDPE-based material. So that is an interesting result too, in terms of using the proper materials for the dredging, discharging pipeline systems. And then let me take you to the third areas of improvement. It's about the floats. You see, being so close to our customer, we saw the difficulties of operation related to the floats. And, floats are rigid, thermoplastic made, and you can have it full of polyurethane or foam or empty. But at the end of the day, you needed to assemble, disassemble, and there is a lot of activities going on, especially in the open sea sometimes. So we decided to try a different type of approach. Which is to make the floats inflatable in order to reach very important results in terms of efficiency of the operation. And you can easily imagine where this type of improvement affects your operation. The thing is that we found out that we could use military grade material in order to have the floats inflatable and resistant to impacts, punctures, and so on. This type of product is inflatable in few minutes and deflatable in few minutes, and can be put around the pipe very easily. So, and also, if you have to assemble or disassemble, it is a matter of minutes, and you can load a lot of this type of floats, up to 300 of these in a container. So it makes a lot of sense when you have to move lines or put in a different place your floats. There is a lot of savings also on this. And finally, let me take you to the 4 areas of improvement, which is currently one of the latest part of our research and development, and we have already some evidence of that. It's about making everything data-driven. It's the mantra of these days, having a lot of information about what's going on in your operations and your devices, and make sure that you can use it for improving the efficiency of the activities, or making decision, or predicting whatever could happen. What we have done is introduce sensors along the pipeline. It's not easy. It's not an easy job. We teamed up with sensor companies. Actually, our partner is an American company. And we put in every 200 meters a section of the pipe with a lot of sensors. You see pressure, thickness, temperatures, weight of the material that goes through, and the turbidimeter. For us, it's just a matter to install these sensors in a very specific section. And the problem we found out, and I want to share with you, is that we need to power up these sensors, and also the network necessary to send the data back to the dredge, and eventually back to the office. And the solution we found out is to adopt a kind of very highly specialized pontoon where we can allocate the sensor section of the pipe together with photovoltaics or wind propellers that helps to have the energy for powering up the data transmission. And the data transmission is made through a kind of mesh data net that helps the data to jump from a section to another up to the dredge computers, and then from there wherever you need it. So it means that in real time you can have information about what's going on into the dredging pipeline. And this is just to show you that you have a graph with the two colors. So one is the weight that we measure at the end of the line, and the weight that has been estimated through our sensor. You see there is a pretty much they are pretty much the same. So it's a good system to consider. The thing is that you can connect all this data to the dredging operation, to the dredge pump, and you can create a kind of adaptive system for managing the power of the pump. So that helps you in saving energy and fuel. The other thing is having these sensors around every 200 meters. If there is a clogging, you immediately identify the section of the pipe where the clogging has been created with a precision of 200 meters. And in the open seas or in the operation, this is quite a interesting opportunity, because time by time we saw that without these systems, when there is a clog, so you have to go along all the line and check where it is. Beside that, having information about the thickness and all the other parameters of the pipe, you can plan the maintenance and the operation for making sure that your pipeline works in a proper condition, which is another important benefit from that. And finally, I try to wrap up everything from an energy point of view. The pipeline systems has a fuel savings. Don't get me wrong. We saw these benefits, but benefit in energy, benefit in saving fuel, etc., are not easy to combine together. We are in the middle of that, and we know that is not an easy statement to say you save money or fuel or energy. But there is a real benefit on that we are trying to analyze properly and make a good evidence of that. What I can say to you is that a pipeline system with all these features, due to the material that and the innovation in the way of production of that, including also the making the rifle effects, etc., has an impact on the fuel. We saw sometime 70% of saving in fuel for the same type of operations. And of course, this cannot be a statement that is valid for everybody. We made some test with in our test field with a pipeline of 560 millimeters diameter and PN10. That's interesting. In any case, we found out that there is a real fuel saving in that. But also combining all these features, we saw that, and this is a kind of tables that put together all the features, operational and material benefits that we can have. And we are working on a field, in a project where there is roughly 30 million cubic meters to dredge. And we saw that steel, rubber pipeline, self-floating. And our system made with this type of material innovation, code name is KNN, whatever other numbers you see there. You see that we have a kind of real benefit in terms of money. If you have to dredge 30 million with a steel pipeline, you need to have to buy 3 times the pipeline. And the cost is about, just our estimation from the field, $53,000 US. If you are using a rubber type of pipeline, the pipeline lasts more, but still you have to buy 2 times the pipeline, and the cost goes easily up to $80,000 US. There is another situation with the pipeline HDPE based with our materials, anti-abrasive and friction reducer with the rifle effects. And we see that the pipe lasts 20 million, so you need still to buy 2 times the pipelines for having 30 million of cubic meter run out of the system, but still you have a residual life of your pipe for 10 million more cubic meter. And at some point you spend less because you don't need to consider into the project the all 20 million, since you are using just half of the life of the last pipeline you bought. So there are benefits on that. Having specialized product for the dredging application, it's makes sense. That's it is our our main share with you. And in final, yes, the takeaways that I would like you to consider is discharging pipeline is a real factor for profit if made properly. And the profit, yes, comes from specialized solutions, not just a generic solution. And the other interesting thing is that the profit and sustainability go very well together. If we sum up all these things, how much these will cost to put in place? And let me give you just my final remarks. Yeah, the cost is more related, as far we see, about change habits and the procedures. It requires kind of new teamwork for considering properly all the advantages that you want to achieve using the proper solution. And of course, this affects the costing, the planning, the purchasing, the operation department of the company. And we saw that the best results comes when all these people work very closely together since the beginning. From an economic point of view, yeah, probably you need to consider that having specialized solution costs more. From our perspective and the production, the costs are 10–20% more, but because they are last very long, usually they can be considered an asset, not just a consumable. But also, if you have to use an asset, you can allocate the cost according to the amortization. So the overall accounting of the projects have an improved in terms of margin. but again, this depends on the way that you manage your accounting and the way that you consider this. However, the technology allows you to have this long-lasting and high-performance discharging pipeline. And that's all. Just a few pictures about what we do, where we have done this test, this work, where we applied this technology. Oh, here we've been collaborating with the government of Bangladesh and the military production ministry in Egypt. They asked us to share with them what is new in terms of discharging pipeline system for dredging. And also we are working together with a Dutch consortium for zero emission in dredging. And we are the only one that is discussing and presenting results for the pipeline parts of the overall equipment in the dredgings. And that's all. And we are happy to share with you these results. Of course, we are a company, and you see in my presentation there are some code names that are referring to the product, but we know that it's good to share and discuss together how to use better technology, materials, improvement. If we work very well together, it's good for everybody. It's a win-win situation in our experience. Thank you.
Thank you, Renzo. That was very informative. We do have one question, and if you have any more, if the audience has more questions, go ahead and throw them in the Q&A. So David Casebeer asked, it would seem the rifling fins would be subject to accelerated wear since they're more exposed. So how do they hold up compared to the interior walls of the engineered pipe? In other words, do the rifling fins wear out before the wall of the pipe?
Well, if I understand the question, we saw there is a trade-off between the economics of putting the fins inside the pipes and also the benefit that you can have because of these create an effect, a positive effect into the flow, the dynamics of the sediments. And so that took us to consider that we could not put the fins all over the length of the pipe and still have a very good benefits just putting the fins and the winglet in some parts. The trick is to find out the proper position, the numbers of fins that you have to put, and the angles, the curves that they have to create. We started, just to share with you, we started with a lot of things inside the pipes, and we end up with very few because from the designing and the experimentation in the field, we found out that the having too many winglets would not cause the good turbulence inside the pipe. I hope that this answered the question. I'm not sure that.
Well, yeah. So Dave was also wondering just whether the fins, the wear on the fins, whether they last.
Yeah, the fins are made with the same material, anti-wearable material that is in the inner layer.
Okay.
And that is very important. That is very important. Otherwise, you have to go and do the maintenance of the fins.
Right.
But
okay. Yeah. So I had a question again about the fins. You presented pressure. You presented improvements in the pressure. For you showed us for 25% solids, but is there a change in the pressure required just to pump pure fluid with the fins?
Well, that is a tricky question to answer. The sediments and the percentage of the sediments inside the pipes change dramatically the performance of the pressure issues. So there is no just a unique solution for that. However, you still have improvement in that, a very, very measurable improvement on this. We did this with sand and how do you say, the crystal sands, the sand, very abrasive, and the rocks. And we saw a very dramatic increase in productivity because the material flowed very, 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 very well out of the pipe. But again, it depends on the sediments and the way that you manage the percentage of the water together with the sediments. So you have to take this as a rule of thumbs or experience and some from a laboratory. But what we can say, frankly, there is a benefit. There is a real benefit.
Well, thank you. It's been very informative. Enjoyed learning a little bit more about HDPE and how it's made and is improved. If there's no more, are there any more questions from the audience? If there are, go ahead and type them in the chat. I will go ahead and thank you, Renzo, and Tom.
I'm very happy. Sorry for my accent, for my sometimes it improves with a couple of glasses of wine.
Okay. Well, it's almost time for that for you. So
yeah, exactly.
So I want to thank you and thank Tom for doing the technical side of the Zoom. I want to remind the audience that our Dredging Summit and Expo is coming up in less than 3 weeks now. It's July 17 through 20. And new this year, we actually have 5 short courses that we're doing in collaboration with IHC on soil characteristics, trailing suction hopper dredges, cutter suction dredges, hydraulic sand fill. And I believe there's one on pumping as well, on slurry transport and pumping. So that's a great, and of course we have our dredging 101 and dredging 201 courses as well that we're giving. I'm actually teaching the 101 this year. And then also upcoming, our Eastern chapter meeting will be October 10 to 12 in Jacksonville, Florida. Our Pacific chapter meeting will be October 25 to 27 in San Diego, California. And our Gulf Coast chapter meeting from November 6 to 8 in Galveston, Texas. So we look forward to seeing you there. And as Tom, did you want to say something about the PDF about the?
Yeah, so I think you nailed everything there, Robert. Thank you, Renzo, for putting on the presentation. Thank you also, Monica, for helping out.
Yeah.
Robert, obviously facilitating and hitting all the buttons there. Yes, Dredging Summit Expo, if you have not registered, please do so ASAP. And then as far as the presentation, it will be online. If Renzo can share his slides for us, we'll put those online as well. And then I'll get you guys a thank you email later on this afternoon, evening. And that will have the PDH information in there. So please do not send me emails beforehand. And with that, we'll go ahead and wrap it up.
Yes. So thank you, everyone, and have a safe day.
Thank you again.
Thanks.
Thank you again, Renzo.
Ciao.
Ciao. Yes, ciao.